All right, you all should be able to see my screen. Let me,
Yes, Rick, it looks fine.
perfect. Let me go ahead and expand a bit here of what I'm seeing for everybody else. The advantage of having a second screen. All right, so welcome everybody. Thanks, Doug, for moderating the session. Thanks, Art and Jim, for giving us a great welcome and overview. So over the next 3 days, counting today, we're going to hear an awful lot about the great science that's been done in the consortium, everything from reports from each one of the centers through lightning talks, kind of, hopefully a better way of doing posters online than doing posters, and workshop reports, tomorrow a roundtable discussion. So looking forward to that. Let me remind everybody that you can, during the breaks we have scheduled, if you're a member of the consortium, you can go over to Gather Town and socialize there, have your social time there. But what my task today was to talk about the coordinating center. So when phase 2 was started, a coordinating center, which we call M3C, was created here at the University of Florida. And so what I want to talk to you about is over the past 4 years, what we've done in coordinating, engaging, and promoting the consortium. So I can advance my slides. Let's see, here we go. So the Metabolomics Consortium Coordinating Center, that's what M3C stands for, is coordinated, engaged, promoted the consortium in accordance with the following 2 concepts, which I think are important. First, we created a mission statement that our mission is to advance the science and practice of metabolomics and its application to biomedicine by coordinating the efforts of the consortium. And our vision then was that metabolomics will become a common and trusted means for studying human biology, human disease, and of course, being a fan of following things. Hang on.
Rick, you're breaking up both in audio and video.
Internet access.
It might be helpful if people turn off their video
Now
sometimes.
with the I turn off the video.
Rick, if you can hear me,
Okay.
we're having trouble hearing much of anything from.
Okay. I stopped sharing. Can you hear that? Okay.
It's improved a little. We're still getting maybe 2 words out of 3.
Okay. I'm going to go away and back. I will be right back. If I can find the host.
Mike, while Rick is getting squared away, do you want to try sharing some material?
Sure.
Let me see. All right, maybe I'll make Mike the host.
We can get the share screen going here. How's that?
Looks good.
Okay. So I think where Rick got to was that we had a vision for metabolomics to become a common and trusted means for studying human biology, human disease. And then I think where I lost audio was and for the improvement of human health. And then to do this, And
So
services
Mike, I'm
capital.
back if you want me to take over for the next few slides if you guys can hear me.
Absolutely.
I'm
Rick.
going to
You
turn the
can-
slides over to Mike
I
shortly
got one
anyway. but-
sentence in, but with the stop share, so go right ahead. We're on the next slide to implement this.
Okay, so let me
vision.
see, yours, okay. Well, do you want to just keep sharing, Mike, and I'll just,
Sure.
we can do our best to time it. They're animated, but hopefully that way we
Okay.
won't have to switch in the middle of the screen.
Yep,
Okay.
I can advance slides.
All right, so what are our aims and methods? So Mike, next, and you can kind of advance along on the slides. I need you to advance the slide, Mike. There we go. Organizing the consortium, that's what I'll talk about first. Promoting the consortium's work and engaging the range of stakeholders. Mike will talk about those. Obviously, along the way, we've worked closely with the NIH working group and with the NMDR to achieve those aims. So let's talk about what we've done over the past 4 years. First, in organizing the symposium, the consortium, we've organized the annual consortium science meetings like this one every fall. Maybe it's not fall yet, but anyway. In person originally, virtually now, including panel discussions, keynote speakers, and poster sessions or lightning talks. We've organized annual investigator meetings every spring. That's just investigators, not a public meeting, in person, eventually virtually. And the focus on those has largely been on strategic planning and coordination, trying to move the consortium forward and thereby to move the science forward that we talked about in the fall. We've maintained a working relationship with the NMDR, including participation in regular project working meetings. And we've also held regular work meetings with the NIH working group once a month or more often. Maintain monthly steering committee meetings, both for the entire consortium and then separate steering meetings for the CIDC group and the DTC group. You'll hear more about those. Not only maintain the working groups that we had, but created and managed our approval process for new working groups. You'll hear about their reports over the next couple of days. Continue working with the molecular workbench on the API for data integration with metabolomics.info, the website that we created from the consortium center. And then obviously internal working group meetings as well. We've also maintained minutes, proposals, reports, all that stuff. That's all available on the restricted area of metabolomics.info, just accessible by the consortium. Produce sample presentations regarding the consortium that PIs use at meetings. We have also created a strategy document to aid in aligning the whole consortium. And in the last year, about a year ago, compiled a list of action items to direct the last year of the grant. All right, so in promoting the consortium's work and engaging stakeholders, the part that Mike has been more responsible for, and we'll give you more details about in just a moment. Maintain the website metabolomics.info as an information resource both in the consortium and for the national and international metabolomics communities. Created and maintained a people portal. Mike will tell you more about that. Really, the goal is to highlight the members of the metabolomics community. Next, maintained a Twitter presence for those of us who, or those of you, as the case may be, who are really into social media. That has been pretty active. And we've also organized monthly collaborative webinars pairing consortium scientists from most of our centers with their biomedical collaborators. Those have been well attended. Nice chance to show how metabolomics makes a difference. Collaborated on things like academic papers and so on. We have also administered here at UF at the M3C Pilot and Feasibility Awards Program and a training program. We've also facilitated community participation, the outreach part, through our annual fall science meetings and also through some of the consortium work groups that have been open. So we're going to talk about those things in more detail. And now I'm going to turf it over to Mike and let Mike talk about the slides as Mike goes through them. Talk about community engagement, Mike.
So community engagement. So for the last 3-4 years, the pilot funding. So we don't have numbers here, but I'm sure we'll have them in a final version of the slide.
I'll fill in the numbers.
Oh, you have the numbers. Okay, good.
I thought that was in the most recent version, but anyway, I think that the number is 25 proposals or 26 proposals have been received, and we funded, I think, 14 of them.
Okay, very good. So we have a webinar series, the Metabolomics Collaboration, spearheaded by Matt, that brings together practitioners and the technical side of metabolomics to show how metabolomics is actually used in biomedical science. And so that's been organized by M3C. And then we have the experimental design sessions presented by Tim Garrett. We organized a hackathon. I have to say this was an interesting experience in which the programmers from the various groups got together to share their expertise and their interests and their ideas about what might be useful for the furthering of metabolomic software. And then we organized workshops in schools, the SMS workshop on metabolomics from data to wisdom, which unfortunately was canceled due to COVID. So it was all organized, but it couldn't be realized due to the changes in the ASMS method of presentation for COVID. And we had expected to have an in-person event following ASMS in person. That just did not materialize. And then we have the annual Metabolomics Summer and Winter Schools in Gainesville with outreach to trainees presented by CSUM and M3C. Conference participation, Metabolomics Society Conference. We've been participating there with posters, workshops, lunch meetings for international colleagues. The Metabolomics Association, MANA, and we helped coordinate some of the consortium activities there. The American Society for Mass Spectrometry, ASMS, in person 2021. We had an exhibitor booth to reach out to the mass spectrometry community. The American Chemical Society Conference online, organized 3 symposia there on analytics, disease insights, and exposomics. And then an experimental biology conference in spring 2020, that was in person. And then the American Society for Nutrition organized presentations there, also in person spring 2020. Stakeholder communities, we work with a lot of different communities, whether they're clinical scientists, the translational scientists that I'm most familiar with, basic scientists, data scientists, trainees, journal editors, industry, a load of different people that have been engaged over the last 4 years regarding the use of metabolomics in their discipline and how metabolomics is presented and worked with in their particular domains. Then we use technology to facilitate engagement, created a website called metabolomics.info, where we have events, photos, links, consortium grants, a dashboard of minutes and reports of the work that has been done by you all. And then we have a special resource, metabolomics.info, in which we take metadata from the Metabolomics Workbench. We create web pages for each different kind of metadata, so whether it's a study or a project or a person or an organization. And then we link off to the direct resources, the data sets in Metabolomic Workbench, the PDFs in PubMed. And we work with the Metabolomics Workbench in an ongoing collaboration to bring that data in, harvest related data, data edit, and present it using an innovative approach. I'll talk about the technical detail of that in the lightning talk later today. And then, as Rick mentioned, we have MetabInfo, a Twitter presence. The Twitter feed is also shown on metabolomics.info if you're not a Twitter app user. Some site metrics. So in 2021, metabolomics.info had 3,300 unique visitors, and people.metabolomics.info as of this morning had represented the work of 1,767 people. These are people who have deposited or been collaborators on deposits to the Metabolomic Workbench. And so we start there. If any group has deposited to the workbench, the people involved become visible on people.metabolomics.info. Those people, their publications, the projects they've worked with on metabolomics on the workbench, their studies, and the organizations they represent. We have a lot of organizations because some people have moved and some people are represented in more than one organization within their own institution. And then the Metabolomics Tools Wiki, we've also absorbed information on software tools available to the metabolomics community, 192 tools. Now, these data are published, so they're publicly available. The data is published monthly by M3C at People Metabolomics Info /data. You see the monthly data going all the way back to the beginning of the consortium. And then we also have a snapshot data published in an open source repository, Zenodo, at the DOI mentioned there. And these are searchable semantic data sets. You can query them. You can make your own social network graphs. You can do all kinds of different things with them. We'll talk more about that in the lightning talk. So this is what it looks like. If you haven't been there, and if it's been 4 years and you haven't been there, well, maybe you ought to go. So there's the Twitter feed, there's upcoming events, there's gallery, and then you see the link to the people portal at the top, and also information about the work of the consortium and the dashboard. And so you see that there, different meetings and minutes and notes of everything that has been done here. People portal we'll talk more about, but you see it here. People, publications, projects, studies, organizations, tools, famous people as they flash by. You see the latest publications and latest studies and a map of where the people are from. And then when you go into the people, you see various people in alphabetical order, and then the institutes on the side. And then you can click on an institute and just see the people that are represented at that institute. That's what a person looks like in the people portal. You see a photo of the organization, contact information, who they work with, projects and studies that they were involved with at the workbench, and recent publications. There's projects, again, with a selector on the left by organization, studies with a selector by year. There's an example of a project. And that's what we have through the presentation of the workbench. Rick.
Thank you, Mike. Thank you, Rick. We have some time for discussion.
I'll just make one comment that I didn't get in since Rick did the beginning of the presentation, which was, I hope you all didn't feel like you were coordinated. I hope you all had an opportunity to do the work that you thought was important for metabolomics, and that we were facilitators. That's really the approach we try to take. To try to take a kind of a gentle approach and let you all decide what work groups are important, what work you needed to do, how you needed to approach your coordination, and let us work mostly in the background. So sorry if we took up your time today telling us how we stayed in the background.
Mike, I have a question.
Sure.
I was just thinking about the utilization of the resources from the program in different communities. And I'm wondering about whether, sitting sort of at the center of the consortium, as you guys have for the past several years, if there were communities that surfaced that started making use of the tools being developed that surprised you. Researchers coming at this that weren't who you expected to see.
Well, I can't say it was a surprise for me personally, but I think it may have been a surprise for some of the people that we worked with here, which was the interest in epidemiologists in large scale application of metabolomics. So we worked with people who were very interested in processing samples on tens of thousands of people over the course of time. And so building mechanisms for doing that, protocols for doing that, measurement standards for doing that, that was a challenge. And I think this consortium was more focused on some technical issues and advancement of identification and other things that weren't immediately applicable to studies of that nature. So I thought that was an interesting, just a group of people that was new, I think.
Thanks, Mike.
I would comment that I think that we saw a lot of people were expected to be engaging in with metabolomics during the last 4 years, but I think a lot of new folks that I don't think we had seen on the radar screen. Some in biomedical and clinical spaces, some in fairly diverse spaces around that who took advantage of the technology that was being developed. So I think that's been rewarding. I would agree with Mike. We certainly appreciated the opportunity of this last 4 years to help move the community forward and to move the science forward, and hopefully did that in a way that, you know, was supportive and not in any way, you know, too much involving control. And I think that over the next few days, we're going to hear a lot of cool science from the centers. So so it's I think it's exciting to be able to pull all the science together here and kind of celebrate the accomplishments of the consortium over these next few days.
I also hope that, and you know, it was kind of an unusual opportunity for us academics to be involved in this, because you know, many of these things go to firms that do it regularly, and I just want to applaud the NIH and the RFA writers for giving an academic group a chance to do this, and hopefully we did some things that were interesting.
Shankar,
Shankar's got his hand up.
I just wanted to make a comment that I suddenly got a call a few months ago from a professor at the University of Augusta in Georgia, asking me to be on the thesis advisory committee of one of his students. And she had nothing to do with the science. It was, in fact, they were working in some sociology unit, and they wanted to do use the metabolomics workbench as a reliability and trustworthiness of data resources. And so they chose Metabolomics Workbench after doing investigation of large number of different data resources. And they thought that this is a good one for them to look at it. So her thesis is going to be centered around Metabolomics Workbench. So I thought this is quite unusual. You asked the question whether there is something unusual about communities that are not normally engaged in this. And I thought I'd mentioned this as in the passing, as something that happened recently.
thank you. That's interesting. We have a question in the chat. What is the focus of this field in cancer research thus far?
I'm sure a lot of people can comment on it, but let me add, cancer, metabolism in cancer is becoming extraordinarily important. As an example, the altered metabolism in cancer, that's the subject of innumerable papers over the last couple of years in leading journals. IDH is a classic example of a gene that is being implicated in cancer. We have a number of studies in the Metabolomics Workbench on cancer, and there is NCI, as you know, has really invested now in terms of looking at cancer metabolism. So there is a tremendous amount of interest, Gopal, in cancer research in this metabolomics field.
John, you have a comment?
Yeah, just amplifying what Shankar just said. One of the big stories in cancer is the relationship between metabolism, the microbiome, and checkpoint immunotherapy. Jan Wargo's group at MD Anderson found those associations. We're working with them on the subject, but needless to say, immunotherapy is at the forefront with respect to new ideas and new developments in the field.
Okay.
I raised that question for a reason that what is the role of metabolomics in predicting cancer, number one. Number two, as well as judging the efficacy of the treatment, whether it's immunotherapy or chemotherapy. So that's the present attention of this field in cancer. I think is gaining momentum, both for prediction of the progression of the cancer itself, as well as studying the efficacy of the treatment, cancer treatment. Thank you.
So I would like to comment on that. Can you hear me?
Yes,
Sure.
Mukesh, please.
Thank you.
Yeah, so at NCI, our program is for epidemiology. I'm in epidemiology and genomics program. So we wanted to include metabolomics in cancer. So the way he was asking Gopal that how in risk assessment, or treatment or response to treatment we can do. For that, epidemiological studies are done where we select a population and collect information about lifestyle, exposure, genetic background, and all that. Along with that, biological samples, which we analyze only by, not only by metabolomics, but by other means also, whether it is transcriptomics, epigenomics, and others. And then we combined, and based on that, prediction models are made. Some are risk prediction models, some are for response to treatment. For example, in colon cancer, left side of colon and right side of colon, they behave differently. One side has methylation phenotyping, which is called simple phenotype, another is not. One side is responsive to treatment, another is not. In that, lot of metabolomics information is helping us. And based on that, Krista initiated that COMETS program, which is Consortia of Metabolomics Studies in Epidemiology, in which more than 70 cohorts have been participating. So we keep track of samples and data elements so that people can see and design their experiment. And a lot of efforts are there for multi-omics integration and how to interpret for biological implication in diseases like cancer. So those were my few comments.
Thank you. So what's the role of epigenetics, which is also gaining momentum these days?
Yes, so epigenetics is also there, especially like our program is the one which have done largest genomic studies by jivas and other means. So many times what is observed, for example, in breast and prostate, we had a cohort consortia. So initially we thought that genes will tell, or their exome, that where is the mutation, where is the SNPs or changes, and that should tell functional characterization. But after characterizing many jivas and others, we observed that those SNPs and other things were not in the coding region. It means it was something else. Then in the promoter and other region, those CpG islands were looked for, as well as histone modifications or microRNA profiling. And that showed some interest. And this we now combining with the microbiome information. For example, in pancreatic cancer, oral microbiome, they make such metabolites which can affect pancreatic cancer. They go through the GI tract and then can induce. So not only short chain fatty acids, but spermidine, spermine, all those affect. So those kinds of correlation are coming. So metabolomics, that does not do alone. Epigenetics is involved before transcription. And then genomic background is always there, especially environment or lifestyle factor or behavior, whether it's stress, aggressiveness, or infectious agents, those affect epigenome first. And by chance, I have been involved with epigenome roadmap program also. Previously, it used to be called roadmap, now common fund. So in that, idea was that in 111 kinds of cells, we do this epigenome, whether it is chromatin configuration or methylation or microRNA and all that. And then we found, and since genomics was also done, so when we compared side by side at embryonic stage or 8 cells or 16 or 32 stage, you don't see genetic changes, but you start seeing epigenetic changes. So during the early life stages, epigenetic changes are there. So those are equally important than other omics. So in this cancer also, epigenetics is so much involved. It was little longer explanation, but I wanted to give background.
Yeah, thank you.
Doug. So Lena posted a very nice bubble chart link in the chat, which shows that cancer is actually the most common disease mentioned in a metabolomic study posted on the workbench, with diabetes second. So very common, a lot of work being done.
Yeah, thanks, Lena, for
And recently, just 2 months ago, we published a review article, which is analysis of what kind of metabolomic studies are being funded by NIH and in how many this integration with other omics is there. So that in metabolomics, just it was appear.
any additional discussion? Well, thank you all for contributing to that.